Good afternoon to all. I, Hashmi, co-coordinator of this FTP, welcomes you all in second session of today's faculty development program on latest trends in computer vision technology and application in Mahakal Institute of Technology in association with TEQIP 3 RGPV Bhopal. Today we have Dr. Mohammad Farukh Hashmi, Sir, Assistant Professor, Department of Electronics and Communication Engineering, NIT Warangal, is being with us as eminent speaker for today's session. Now I would like to call Professor Prachi Jain for briefly introduce to Sir.
Okay, ma'am, thank you. Dr. Mohammad Farukh Hashmi sir received the BE degree in Electronics and Communication Engineering from RGPV Bhopal University, the ME degree in Digital Techniques and Instrumentation from SGS ITS Indore RGPV Bhopal University in 2010, and PhD degree from the Vishveshwaraya National Institute of Technology, Nagpur, under the supervision of Dr. Avinash G. Keskar. He is currently an assistant professor with the Department of Electronics and Communication Engineering, National Institute of Technology, Warangal. He has published up to 60 articles in international national journals and conferences. He has a teaching and research experience of 10 years. His current research interest includes computer vision, machine learning, deep learning, embedded system, Internet of Things, digital signal processing, image processing, and digital IC design. He is a member of IEEE, LMIETE, ISTE, and LMIAENG. We welcome you, sir, and it's an honor to have you and listen you, sir. Thank you, sir. Over to Rashmi, ma'am.
Now I request to Dr. Mohammad Farukh Hashmi sir for continue his presentation.
Thank you, madam. Very good afternoon to one and all. And today I am going to talk regarding the application side of computer vision with respect to machine learning. So yesterday from my first session, I have discussed about machine learning. With respect to machine learning, basically we are working on deep learning. That means whatever the neural network initially we started utilize in different applications, and also we have covered that same application in image processing, computer vision, machine vision. So these are the areas are available in today's trends, because mostly we are working in current technologies are available to automate it to each and every application. So with respect to each and every application will be automated, we need to provide a vision, and also we need to provide a decision making capability inside the system. So based on the computational requirement, we already are using with respect to different processor technologies and with respect to different computational algorithms. So anyway, these are the discussion we have finished yesterday. We have also gone through different application side, what are the applications are there in computer vision in a different area. And these are the workshops title recent trends, whatever the current trends are there in computer vision. So there are computer vision applications already we are working in our lab with respect to available resources. So basically I am working in object detection from the past 10 years. With respect to initially when I started, the object detection was not up to that perfectly available due to the unavailability of the perfect algorithms. And today is what we are doing. We are having so many high-end machine learning algorithms are available. That means we are capable to recognize object in a particular high manner and accurate manner, and that applications will be helpful in different applications. So today I will talk about object detection And also I will talk about one of the applications area, that is sports. How the computer vision will be helpful in sports. So that is called sports vision. So basically, we are watching so many sports in India. Mostly, we are watching cricket, and we know cricket are how much are capable with respect to vision. So many decisions are nowadays are taking very less time. If you see 10 year back and if you see today, so every year whatever the technologies are coming, it is going to involve in different kind of sports. And one more application, one more sports is many people are watching in the world level, that is called soccer. So it's a very well known and well famous sports. So there are different decision making and there are different application will be required for that side. So I will cover of that. I will show some of the paper also, what are the research is going on. So basically this talk I will cover with respect to what are the research as we have done in our lab and what are the research people can pursue in that area. So I will start from the first application, object detection. I will talk about my related applications, as well as I will talk sports computer vision. Yes. Uh, is it okay, sir? Mohit, sir?
Sir, the screen is not visible right now.
Your PPT is not visible, sir.
One second. Now is it okay, ma'am? Mohit, sir?
Yes, sir.
Yeah, yeah.
Now it is visible.
Yes,
Yeah.
sir.
Make it slideshow, sir.
Yeah, I am going, sir. It's taking time actually. So
Yeah, yeah. No problem.
PPT is taking time to open it. So object detection is a computer vision that we are going to talk. So object detection is basically is a computer technology that related to computer vision and image processing that deal with detecting a various semantic objects of a certain class. So that means we can detect humans, buildings, cars in a digital image and videos. So well research domains of object detection includes, there are different researches going on like face detection, pedestrian detections. So object detection has the different application in many areas of computer vision, including image retrieval, video surveillance. So it's a widely used in computer vision tasks such as image animations, activity recognition, face recognition, face detections, video object co-segmentation. So basically what we are using here is also used in tracking objects, because in a sports we are tracking a ball during a football match, or tracking a movement of the cricket bat, or tracking a person in a video. So for that, we are going to talk with respect to different class. So as we know very well, yesterday we have seen there are different features are available inside the image. So we need to extract the different features. So special features that help to classifying the class. For example, circles are round. So we need to track that particular region of interest, or we have to identify that circle. So object class detections uses that is the spatial features. For example, we are looking at circles in the object that are particular distance. So similarly, there are different kind of corners are available. So or we, in terms of face identification, there are some eyes, nose, lips are found. That is also feature. or skin color or textures. That is also one kind of features we can recognize. So whatever the contents are there in our case, we'll talk what are the deep learning, what we are doing. So anyway, that means we are working with respect to machine learning. So deep learning is the tool for us how to detect the object. So object detection model predict the bounding box. As already told, there are different features will be required. So how we can determine the objects are available inside the image. So for that, we need to predict that bounding box, one for each object. It's fine. As well as we have to classify. So classification will depend upon the types of probabilities for each object. Suppose to be one picture you have captured. In that picture, there are certain objects are there, certain humans are there, or certain non-living objects are also there. So we need to prepare a bounding box, and with respect to bounding box, the particular probability will also calculate. So that can be helpful in intelligent traffic system and real-time accurate detection of the pedestrian images, videos, data are very important for us and challenging work, especially in situation with complex scenes. That means supposed to be there are multiple objects are there are multiple humans are available in the scenes, or like in sport there are different players are playing, or their location is different. So with different models, high density, it is very difficult to accurately locate the pedestrian during the traffic flows. And also object detection system usually employ a bounding box, pixel resampling, and application of high quality classifiers. So ultimately, we can classify the particular object with respect to high quality. And these approaches are heavy on computation. That means already I told, if there are multiple features calculation will require, it will create complexity. That means computational complexity will become more and more high. So, and high latency, as already told yesterday, latency is one of the also requirement which comes in real time application. That means supposed to be same system we want to apply on a particular board. So that board should have that kind of capability to handle real time. That means if suppose you are watching a cricket on your screen, that means in the ground it is taking around 3 to 4 minutes or some 1 minute delay. That delay means we can say it's not perfectly real time. So that means the computer vision societies are working to make that particular video should come at real time. For that, latency should be reduced. So like that, we can see this example in this figure. We can see pedestrian detection, human part localizations, or general object detection. So you can see object detection simply in that first image, first frame of the video. We have recognized one human, one lady, and also recognize one of the object like one animal. And based on that, supposed to be in the crowd, there are multiple peoples are moving on the street. So we can recognize the pedestrian first, and some pedestrians are occluded or combined. So our algorithm should detect properly that pedestrian and should separate. So each pedestrian will give some probability. So we need to apply deep learning. We need to create a like human brain, kind of human brain. So that means we can align face, we can align human face estimation. So like a different kind of activity also we can recognize, different kind of pose also we can recognize. Supposed to be one event has happened, some peltier, stone peltier event has happened somewhere. So if the camera will predict who has done, who has not done. Such kind of event we can easily recognize with respect to computer vision. They'll apply deep learning. So we jointly learn different components. So for that, feature extraction will be required. We can also apply part deformation handling. That means with respect to that particular body, what we have calculated, that parts can be separated. And also we can handle the occlusion. There are different areas are there we need to work. That is called challenging areas. One thing, illumination is one of the problems. Second thing, the clubbing occlusion of the objects, or different vision like night vision also will be there available. And finally we are applying classifier support vector machine. So this was the paper was given 2005. So 15 years back, people were doing like that kind of work. They were creating a feature extraction technique and based on that. But the problem was simply based on the accuracy we were reaching. But other parameters like precision recall, it was not able to predict actual value to actual and false value to false. That means false rate was more at that time. Now ultimately every day we are reducing the false rate. Also we are working on the real-time manner. So there are different data sets are available with respect to different object detection techniques. Like Pascal work as data set is available. That is having 2007 data set and also having 2012 data set. So these data sets are having 20 object classes. For that training, we are using 5,700 images. For testing, we are using 10,000 images. So there are multiple data sets are available, and more over million images we can identify, or we can predict the particular object as well as classify the object. So we can see in the first frame, second frame, there are different objects we have recognized. Sometime it will miss. So another data set ILS VRC, it was also having 2000 object classes, but training will require there are 39,500 images, and testing also 40,000 images can be tested. So you can see there are different bounding was created with respect to our method. So in that case, person also detected, car also detected, motorcycle also detected, helmet also detected. So we can segregate the particular object inside that video. So that there are different data sets we can utilize. So ImageNet data sets will have images with respect to 450K, and classes also 200 categories classes are available. It was updated to 150. Coco data set, it's having 120K data, get images, and it will have 80 classes. Similarly, it was updated to 140. Pascal work data set was updated on 12, will have very less as compared to other two data set, 12K. And Oxford IIT PAD 7K will have 37 classes, and on 12 it was updated. TT data set, that is also for vision purpose, 7K images are available, and there are 3 classes are available. That is very simple data set, only a simple 1 or 2, 3 classes are available. But if you want to work more and more data set, definitely your method, your algorithm will sustain all kind of information. So as we know very well, what are the issues are happening with respect to any object detection techniques. So existing methods are computationally inefficient because of the real time and smaller pedestrians. So that means pedestrians are very smaller. So we need to predict the pedestrian in a high or accurately manner. So there are research related to fast and efficient algorithm for real-time pedestrian detection that can run on a low-edge devices. That means small devices, like you can implement your system on your mobile phone also. Now, because mobile phone having 120 GB, 256 GB, even 8 GB memory is also there, but that configuration is opposite to different whatever the configuration we are using on the system. But we must try on that. So that means real-time behavior can be tested by lower edge devices, as we are using in our lab Raspberry Pi as well as Jetson Nano or Jetson TX2. These are the some hardwares have arrived with the help of NVIDIA. So NVIDIA has given there a number of cores. Nowadays every system will have GPU, and also we can utilize online GPU, that is what Google Colab. So Google itself has given his own server. So people are not able to wait, or they are not going for any worry about that. They can run their system with respect to Google Call, but that is also somehow efficiency will be required in our own system. So anyway, to improve the detection accuracy, to improve the speed while detecting the smaller and dense pedestrian under the unmanned real-time traffic scene. So as we are working or any kind of internet transport system application, so that means traffic is one of the crucial area where the different kind of objects are available in terms of vehicles, in terms of different kind of vehicles. So the category of the vehicles are also more and more. So for that we need to know some more data set with respect to different detection of accuracy as well as speed. So the related with the problem statements, we are working on different problem statements. As already told earlier, we worked based on the vehicle detection with respect to region of interest. That means in a scene, that particular pixels are moving in a particular region, particular area, and we are just calculating that. But in that situation, there are some different pixels also because of motion. So as we know, the video are having different motions. So it's a video, nothing, it's a number of frames are coming with respect to frame rates. So based on that, different pixel also will arrive. That means false pixel also will be calculated. For that, we need to work on different performance values like precision records. It will depend upon the false positive and false negative. These are some parameters, true positive, true negative. So we need to calculate this all parameters. Based on that, we are able to identify the accuracy of the system. And also for the latency point of view, the system will work based on the different frame rates. So it's also one of the challenging tasks. So that means frame rate, if it's very low, that means system are able to perform the application, but it will take time. So the output will come sometime later. So in that case, we cannot say it's a real time. So nowadays, the availability of the high GPU or availability of the computational resources, we are not facing such kind of problem. But based on that problem, we have to work for that. So that means what we can do, that there are some data structure need to be applied. Otherwise, what will happen, the data will have, that is a garbage data. So ultimately in data structure, we have studied related dynamic memory allocations. So we have to manage like that. So ultimately what we are doing here, we are writing a program with respect to different open source library like OpenCV. So OpenCV is nothing, it's a Intel open source library. With respect to OpenCV, there are different versions, and there are different kind of programming codes has developed by the different researchers society. And what is the main advantage? We can work on open source platform. Like particular platform we are using mostly in all hardware with respect to Linux based system. So Linux is open source. So like Ubuntu is one of the platform. We can install the Ubuntu. We can install all library with respect to simple commands. So based on the command we install. After that, we can develop your own architecture. Like already yesterday, I told there are different architectures are available. Based on the available architecture, you just change the layers as per your applications. So if you have changed your layers, if you change your own pre-trained model, somewhere we can start from the scratch. Somewhere you can utilize transfer learning. That means you can utilize the pre-trained model because of availability of the resources. If you are having laptop, if you are having small system, you can do by pre-trained model. So there are existing methods often lost. Some of the part of detection accuracy is very low. While detection of smaller prediction in order to meet the real time and road environment. So particular road are having different structure, like somewhere T structures are there, somewhere some different five junctions are there. So depend upon the cluttered environment of the road, that means number of vehicles will increase, number of vehicles will be more, prediction also will be more. So for that, we tried initially with respect to pedestrian detection using enhanced TV YOLO 3 network. That means this network we have designed, and also we have developed this system with respect to our own, and we have verified there are different data sets. So what is the basic work we did here in this proposed work? That robust enhanced TV YOLO with 3 network is designed by introducing the anti-residual model. That means we added anti-residual model which help to improve the network. So that means whatever the network is available, we have taken that network, but we added this this technique, anti-residual model, which will help to us to improve the network feature extraction capability. That means earlier whatever the capability was there, it was having some level. We have improved that one. So in that case, what we did, the loss function has improved. So it reduced the bounding boss loss. That means somewhere bounding boss or unnecessary was coming. So we have to avoid that. So unnecessary bounding boss also will take some more time to process. So ultimately latency also will reduce. So by that way we can apply on hardware platform. So this one prediction scale size is 52 cross 52 is eliminated from the that network, and which is also optimize the network. That means we need to apply some different optimization method with respect to gradient or other methods are available, as we have to include that methodology with respect to optimization of the network. So once we optimize the network, we need to try. So that real-time predictions will require some tool, that is a single weight linear network unified architecture. Framework is a darknet. So that is a framework we have utilized. Technology for the background we have used related methods are very slow, so no real time, avoid generalizability. Solution, we have created simple structure of the network and it is much faster. I already told based on the frame rate. So in terms of our own hardware, like our system Jetson Nano, we tried up to the 220 frame per second. So that is able to process stream of video in real time, which is less than 25 milliseconds of latency. That we can say now, sir. So real time. So if the 22 frames per second we can try, but it would happen different kind of video. We cannot say everyone. So like sports, like a different, but anyway, whenever the car is moving in a particular video frame, it's very fast. So it may be more than 60 frames per second, it may be 80 frames per second. So we need to work for the frame per second side. That whatever the data set we utilize, we have tested up to that, and less than 25 millisecond our the latency was achieved. So mainly we have maintained the proper accuracy. So these are the implementation we did and we have verified. So this is the architecture we have improved. That is whatever the TD YOLO V3 architecture was there, in that there are different add-ons things we have done. So we started from our input, that is as a frame, and we have verified different convolution layers. So we have changed the convolution layer with respect to our requirement, that means feature extraction. And after that, what is the maximum part we did, that is anti-residual model. You are able to see here that the maximum pooling size. That means we have reduced the dimension. As yesterday I told regarding the maximum pooling weightage of the maximum pooling, we can reduce the particular dimension of the features. So feature map has reduced some more level, and whatever the maximum special feature was required, that we have targeted. Based on that, we have included, we have clubbed, and then we have sampled, and finally we again given the convolution, then we have created the output. So these are the real-time detection we did by the enhanced TD. That means we are saying it's enhanced version because we added anti-residual models. This is our novelty from our side. So what exactly is happening anti-residual model structure? So in that case, you can see the maximum pooling was done by this particular filter. In that, what is the slide we have used, that based on that we have done. And then finally we added total architecture with respect to depth size, and finally last we utilized the maximum pooling in 2 cross 2, and that would be added with respect to another pooling convolution 3 cross 3. So this is the anti-residual model structure we applied. So this is the network. What is happening backside of the particular mathematical information. So yesterday I didn't talk mathematically because mathematical requires some more discussion. It should be require some one-to-one discussion. So the loss function of the enhanced TD YOLO 3 is improved, and it is defined by 3 terms. That means what we have calculated exactly. Position coordinate error term, that means we need to predict the error where it is happening, so we can calculate the position of that coordinate error term, and confidence error terms, and classification prediction error. That means our requirement is we have to reduce the classification error. So these are the some mathematics is happening behind the code. So we have to create this mathematics so that we apply it on our system, on our architecture. Then based on that, our that means accuracy was improved. So based previously what we have done here, whatever the coordinate we have calculated, that is position, and whatever the coordinate we calculate, confidence error, the classification. So lambda coordinate, the xi, this is the x and y coordinate. With respect to that, we calculated whatever the object we calculated. Based on that, we applied. This is the mathematical model. So now you can see real-time prediction results. So that means whatever the methodology we applied, that we can see this is the predictions are available. So there are multiple predictions are available. You can see there we have applied bounding box, and each and every person will have some probability 0.79, 0.8, 0.9. These are the mean average precision. That means what is the probability accuracy of that. So sometimes it's coming from 90%, sometimes it's coming 20%, sometimes. So our task, we need to determine maximum accurate prediction with respect to different data. So this data set that we applied. So this is also some more results with respect to different frames, whatever the data set. So we are able to see the persons, sometimes it's a 0.8, sometimes 0.9. So the error, we are able to reduce the error. So our main aim is to reduce the error with respect to our data set. So finally we have that is prepared the results with respect to YOLO V2 and YOLO V3. So the speed was improved with respect to, and accuracy also was, so improved TD YOLO V3 also was there. So we have applied our own architecture, and in Asst in YOLO 3 we have received around 78.6. Still we are trying. Our detection as a proposal algorithm is still low. That means I am not here to say this is the correct and good accuracy. This is some accuracy we reach. Now still we are able to increase the accuracy with respect to improvement in the architecture. So that we are doing. So this is a general object detection. If we try one or two objects, that definitely it will detect perfectly. So that we are doing also many tasks. So for that also we started to improve some more accuracy. For that we have find out another problem statements. In that case, we are applying same default bounding box. So SSD consider for each feature map in isolation. That means we had applied SSD. That SSD will calculate the each feature in a different isolation task. So it cannot exploit the semantic information. So whatever the layers semantic information will be there, based on the abbreviation initial layer. So finally, SSD does not perform well on the smaller size, but it will have the problem. It will not able to perform smaller object because supposed to will apply in terms of particular sports, so that small ball is very small. It will be very hard to bulk initial layers. So SSD need to evaluate several thousand of bounding blocks. That means there are moreover so many bounding blocks are coming. So several thousand bounding blocks to detect only a few object elements. So design a better default bounding box. That means we are here to define what kind of bounding box we can improve. So we have designed better default bounding box will help to improve the accuracy. To achieve real-time penetration without loss any part of the detection accuracy, these are the problems we are right. So now we did one thing. We clubbed two architecture STD plus VGV model. So we have developed this model and that failed to detect smaller and dense predictions. So shallow convolution feature map we added. So this is the methodology we added to propose network, which enhance the feature information to improve the detection. That means that it was failed in terms of small and dense prediction. So this proposed method concentrate more to extract the best layer parameters. That means what are the best hyperparameters are available, we have to extract, because whatever tuning we are doing on the hyperparameters such as depth, stripe, filter, shape, optimizer. So as yesterday we have seen the any neural network architecture, these are the parameters. The depth is one of the parameter which is to decide the kernel. Stride, we need to decide how we will stride the kernel. And filter, whatever the kernel we are choosing. So yesterday we have seen there are so many filters are available. So we need to perfectly tune this parameter and shape and optimizer. So whatever the optimizers are currently we are using, even activation functions also. So play a vital role in optimization of network. And also it will helpful in terms of reducing the computational power. That is ultimately there are multiple computational processes going on. Third is one of the person had asked the question. They are using from the screen, it will time taking. For that's why we need to provide the optimization task in our work so that computational power will improve, so it will not stuck somewhere. And while execution, it will improve the detection. So these are the basic requirement to do in our task. So we are using tool a single deep neural network framework. We have utilized Keras, and technology background. We have utilized the method structure and how to bring high speed and good accuracy. So for the solution side, we have provided uniform framework, much faster, better accuracy. Even with smaller input image also, we can do much better. So this is the architecture, whatever the architecture is available. So in that case, we utilize MobileNet, and the MobileNet extended by the detections, that is 8,732 per class, and we had applied known max suppression. So you can see image size of 300 cross 300 into 3, and in that case we have created mobile net architectures. So you can see the mobile net architecture will have different convolution layers, 4 cross 3, 3 cross 3, 38, 38 to 56. These are the in particular layer 0 to 13. This mobile net is applied. After that, next we can calculate different convolutions. So these are the architectures are available. So this is the real-time prediction for computer network using optimized mobile net plus SSD network. That means we have proposed mobile net plus SSD. So based on that, for speed structure advantage, limiting bounding was proposal. So whatever the bounding was proposal was there, it was eliminated. Subsequent pixel or feature resampling step. So adding convolution feature layer to the end of the truncate based network. That means whatever the truncate based network is there, we added convolution feature there to predict the detection at multiple scales. So we can predict. So what do convolution feature layers do? That means we can say this is the image, this is the feature map after the convolution, and that means finally whatever the convolution layer will be there, we have localized, and that layer of confidence matrix will be given. So 4 cross 4 mesh feature map was calculated with the help of convolution. So why it is required? As yesterday we have seen there are different convolution we are applying. So for that need an input image and ground truth. That means first of all we need to detect whatever the object calculated. We should have the correct object detected. So that means we'll compare our performance parameter with respect to ground truth as input image. So we require input image, ground truth boxes for each object during the training time. So if you give training time, this is the object, they should be detected, and finally we'll compare it. So we have evaluated small set of default boxes of different aspect ratio at each location in several feature maps with different scaling. So with respect to different scaling, we have calculated with different feature maps. So these filters match the default boxes. So whatever the filter we are able to utilize here, we can match with this filter with the different default boxes and with respect to ground truth boxes. And once we calculate this thing, we'll predict the both shape with the respect to offset and confidence for object category with the default boxes. So the feed forward convolution network produced. So whatever the feed forward network we have created, a fixed size of collection of boundary box and scores for that presence of the object in particular boxes. So for that we need to determine the quality choice. So for that we are imposing the different aspect ratio for default boxes. So whatever default boxes we utilize, we'll choose different aspect ratio and denote them like that. So 1, 2, 3, 1 by 2, 1 by 3. And instead of using negative example, SSD short them using the highest confidence. So every time it should not come under the negative side. So SSD, what SSD will do, it will short out the particular highest confidence. So whatever default box is available, what is the highest confidence, and it will pick up top one and take the ratio between negative and positive at most 3:1 and leading to faster optimization. So by that way, it will optimize and it will be able to provide more stable training. So this is the quality choice. Then later we need to identify the loss function. So we need to calculate some mathematical analysis. The overall objective loss function, it is a weighted sum of localization. That means whatever the loss we are able to get with respect to error, because we need to choose a perfect weight. So that means error should be reduced. So for that our objective we have to calculate the overall objective loss function. So here number of default boxes also we need to apply. Whatever the predicted boxes also we need to calculate. What are the actual boxes we have created by the ground truth, and also we need to denote what particular certain condition x equal to 1. So that is the default box is matched with ground truth. That means correctly whatever box you tried, whatever box it was matched, it will show the value of 1. So this is the way we can reduce the loss function. So MobileNet, what exactly is doing? Substantially reduce the complexity. So with the help of MobileNet, we can reduce the complexity. Also, we can calculate amount of calculations and also speed up the training process. That latency will reduce. So we have used 3x3 kernel, saving the computation by new approach about 9 times faster without making any difference detection. So what is the method we applied here? So mainly we applied input side. So we have trained the data with we have, as we know very well, we have to label the data as we are using supervised learning. So we have given the training labels, testing images, then output we have said detector result. So we have created one class, we have given the data with respect to that class. After that, we have trained our network. So calculate prediction value, whatever the D value is coming according to training data. And we have proposed our optimize whatever the network we have created by forward propagation and calculate the loss between D and label. So what we have predicted, what we have calculated. Based on that, we calculate the data, and that information will be updated with next parameter with respect to back propagation. That means we have to test whether the correct data is arrived Otherwise, we'll again go to back and we can change the weight, and also we will come back like that. This process will happen in the training time. Then at the time detection, we can calculate the prediction category, and also we'll apply a regulation offset for each bounding loss in a multiple prediction layers. Then we can decode the bounding loss for testing the data, and we have choose particular prediction box. Also, we had applied non-suppression method to filter the highest overlapping box, and we got the result with respect to particular class. So this can be processed by the detection side. So whatever the proposed method, we use a adaptive moment estimation optimizer. That means we have used ADAM. This is optimizer. We have replaced SGD optimizer that was used in SSD and VGG network. So this replacement we did. And while training on the Pascal 7 dataset, finally we model tested on to work dataset. The experiment was carried out on workstation during the training phase, and we have done the testing on Jetson Nano evaluation board. So that means we have the evaluation board. That board has been given by NVIDIA. It consists around 4 GB RAM. Also, it consists about some 200, 300 GPUs cores. So that would be tested on that. So this is the our performance curve for the optimized mobile network. So how the ROC will vary as for the form. So like that, your loss function is varying with respect to different precision and recall. And we have tested the result with respect to different networks. So RCNN, fast RCNN, faster DPM, SSD 300, that is EG16, YOLO, simple YOLO V2. So we had improved from the YOLO and other parameter, and also YOLO, teeny YOLO, whatever we implemented, so we reached 80%. The accuracy was improved with respect to this all network. And also for the map value also, we got that accuracy. So this is a comparison graph with respect to different architectures. And these are the detection results we have tested to 217. We also tested on 212 data set also, but there are same images are mostly available there. So in that case, we have identified there are different prediction images because there are multiple images are available. We need to identify whatever the prediction image is. Based on that, we have tested for that. So this is the sample detection image of Pascal Wook 7 Caltech prediction data sets. So this is also low resolution. The image resolution is very poor. Based on this, so we are able to predict with respect to their map value. And this is we have verified on the hardware platform. We are able to see the system as we are using in our lab. And that one small board is available. That is it's a nano board. And it's look like same Raspberry Pi, but it will be different based on the availability of the resource. Even this is another figure showing person 0.87, another person 0.7. So like that, multiple objects as a prediction has detected with the help of this hardware. And these are the general object detection we tried. So truck has detected person, same algorithm. We can try by different object detection also. So basically we tried for the prediction purpose, but we have implemented for other kinds. So car also detected 0.98, 0.7 to 0.92. So that is a common category we have. This is a simple only one object inside the two objects inside the figure, or 3 or 4 objects inside the figure we have detected. So here by use of the proposed network, the number of parameters in the network is decreased. That means the parameter what we had applied earlier, it has reduced, and also the detection accuracy has improved. That means we have reached now 80% as compared to previous state of art prediction detection model. We are not talking in terms of only object detection. We are talking in terms of only prediction detection model. So here we can see the proposed model achieve mean average precision is 80.4, and also it runs speed of the 34 seconds. That means we had applied latency side on the Jetson evaluation board. And in some images, the frame is failed. We take the distinct prediction. Still, detection accuracy of smaller object must be improved. That we can try and decrease the memory requirement as much as possible in future work. That is, we are trying still to improve the accuracy for smaller object as well as the next already one more network we have proposed. I'm not going to talk here. That is YOLO V2 and V2 something we have proposed. So we are working on that. So we'll definitely improve the work. So we to achieve the optimum speed and accuracy of pedestrian detection is done by applying the universal features such as cross, mini page normalizations, mosaic data augmentations, and self-adversarial training on the pedestrian data set. For that, to design a real-time lightweight network for detecting off. So we are working on occluded pedestrian environment. So for the future work side, deep learning is very crucial area to extract the dynamic features for video analysis and the model for structured data and qualitative analysis on how to design a network structure. That means we need to work on that, how to design a optimized network, how to choose a non-linear operation in different layers to achieve the different feature invariance and new optimization and training algorithms. And parallel computing also one of the crucial requirements to train very large network, larger training data. That means the 1 million data, 10 million data. If you want to apply, you need to work on parallel computing for same object detections. People are working on that side. So I will talk one of the application same side. Sir, 1 minute. So this is another application of the same domain, computer vision based assistive technology. That means object detection is one of the tasks in this application. But this application will be able to help visually impaired people for utilizing the efficient CNN learning. That means with respect to learning, we can give the one application to the visually impaired people. So for that, this project aims to helping blind people and visually impaired people from day-to-day problems such as normal conversation, navigation difficulties. So our proposed use efficient and accurate object detection algorithm in the domain of advanced computer vision. So I will show some of the slides with respect to application side. So with the advent of the deep learning technique, observation performance has already improved. As we know, observation already is happening perfectly. So the project aims to incorporate the whatever the YOLO observation algorithm is there. We are translating in good encoding API for achieving required goal with high real-time performance. And this observation field of deep learning combined with computer vision and recognize the occurrence of the semantic objects. So that means whatever the semantic objects are there in the image by preparing of bounding box. As already we discussed in the previous slide, previous presentation, bounding box creation is required. But here we are able to create a object detection only. Here we should not talk in terms of spatial kind of object detection. That is either pedestrian, either human, either living object, non-living object, car, anything. So we can that convert whatever the text, that means by annotated text into a voice. That means the person can listen. This is car. This is laptop. This is so we have verified with respect to different scenarios. So give the basic position also object in the person's camera view. So that means the person will have the camera, will have the vision. If the person is disabled, it will utilize that camera in some level and that can be identified. So that is the basically requirements. So people are working for that motivational things. So ultimately, thinking of better solutions. So the task hand can be derived from the naive approach and develop the further upon. So the problem can be broken into major implement. First, what we did object detection, implemented using CNN. Later, we have utilized audio relay to end user. So you are able to see this is the correct architecture or correct building blocks of our system. So we have COCO data set we utilize. There are 1 to 3.27 hand labeled images, 80 categories. And also we created our own YOLO V3 plus darknet. And after that we have developed API, and that could be converted into a verbal site like cat, bounding box plus class prediction. What is the kind of will be available? So here we know what is a neural network, why you are using. So first we need to know convolution methods are very slow as compared to deep learning methods. So conventional methods, whatever we utilize. So secondly, again we want regular neural network for learning of features. For example, size of the image is like very small. That means it will convert into tensor. It's fully connected with different layers. So for that would be 14 million data need to be learned. So it would be very difficult to learn that kind of feature. So if similar thing implemented by CNN, 3072 tensor would be followed by 6 filter. Dimension is 5 cross 5, related 156 parameter. We need to learn. So once feature detector is ready, it can be used any part of the image. That means where we can apply, we can predict any kind of information inside the image. So YOLO, you can see YOLO is you only look once. This is one of the architecture. Mostly people are using in object detection. So it's a deep learning based convolution neural network. It does everything with a single pass of neural network. So put it straightforward image and accept it as an information. The any problem? May I audible, sir? Mohit, sir. Mohit, sir.
Sir?
May I audible?
Yes, sir, you are audible, sir.
Okay. Yes, sir. So, to put it straightforward, image is accepted as information, and go it through a neural network, accept the like typical CNN vector of bounding boxes, and classes forecast are obtained from the output. So you can see the image one that can be predicted the particular object. Besides the image, run CNN and also apply some optimization like non-max suppression. Then they have predicted human, they separated dog and other object. So like that, their probability also will be given based on the. So what is the exactly process is going on? So the image has been partitioned different matrix, and every network that could be detected as a particular bounding box, and particular class also will be there. That means what is the category will be there. Based on the probability also will be calculated. So every class will have different ground truth also. So bounding box forecast has 5 parts: X, Y, W, H, certainty. The XY facilitate focal point of container with respect to network, and these directions are standardized to fall somewhere in the range of 0 to 1. So this is the, and second, formally we characterize the certainty as per the object is there with respect to ground truth, and we can change if not exist in the cell, and confidence scale also necessarily 0. And from the original paper, 5 seconds of 5 box expectation are predicted. Every frame function cell makes bounding box, so that there are different output will identify with respect to bounding box forecast. So that is the technique we are doing. So additionally, classes also will available. We get this kind of tensor. So for the Pascal work, for the YOLO utilize 7 cross 7 network with the limit above. For the class prediction, YOLO V3 utilize multi-name order. So YOLO V3 replaces the softmax output function. So here YOLO V3 we have replaced the softmax output function with classifier with autonomous strategy with respect to classification utility. Now let's get deeper into network. That means we need to define our own specification. So we have created darknet that is used in YOLO. So this is the correct network we have created. So that moreover we have utilized darknet 53 as name proposed. It contains 53 CNN layers, and each pursued by the bunch standardization layer, and leaky ReLU activation function we have utilized for that, undertaking the identification. 53 additional layer are stacked on it and giving us 106 layer completely CNN design for YOLO V3. So this is the correct architecture we implemented, and based on that there are certain we have done certain changes, like first detection made by 82 and layer. For the first 81 layer the image is downsampled, and 81 first layer is a striped by 32. So these are the parameter we did for the our implementation. So second detection made by 94 layer, and it yielding by the 26 by 26. So like that, this is the perfect method we applied for the perfect detections. Finally, YOLO V3 total use 9 anchor boxes. Particularly, we E-scale, we use K-means clustering to generate the 9 anchors, and we arrange these anchors in different orders with respect to dimension, and assign the biggest anchor for the first scale, next 3 for the second scale, and last would be third scale. So this is the object we calculate. So now load of predictions for the same object is observed. So that means first case you can see, second case you can see. So we are going deeper and deeper. So finally, by this way, we by this separation and thresholding, we can predict small to small object also. So for that proposed changes, we what we have done, like we have removed the associate layer, whatever was problem. So these are the architecture side we implemented, and modification was done in the particular matrix. So this is the perfect training model. So we utilize dataset Voco 12 to 12 or 20 classes, that much images. Custom data is 4 classes, and computation phasing we utilize our own system for the Taiwan. GPU is 8 GB. So these are the some augmentation we have tried. So finally, some annotation tool base site. So these are the parameters we did in that. So this is the whole process we did. So the experimental side, we determined the objects. So we have calculated different training parameter. By this way, we have calculated precision, mean average precision, F1 score, test loss. So these are the training loss, confidence, classification. So these are the quantitative analysis we tried on data set. Learning rate we kept alpha equal to 1, x2, and alongside weight also we have kept in equal to lambda point. The weight initialization used for the Xavier initialization. So and qualitative analysis. So among each 20 classes for the current YOLO show, we pick the that much classes that like bottle, seat, chair, individual, book, couch, TV monitor. They are in the classes that we define relevant to the application to be used. So when we have tested around 25 to 28 frame per second, achieve 35 to 40. And these are the benchmark value we got for every object. Motorbike, bottle, bird, cat, chair. Somewhere it is less, somewhere it is. Benchmark value we kept for chair 0.3, but we got 0.6. So our task, we should predict the particular value, convert it into a particular voice. So you can see these are the particular objects we calculated bicycle, and these are custom data set. These are our own we have done in our lab. So you can see the second. These are our library. This is our lab. This is our lab. This is our parking. This is our system. Just and this is the one of the student we tried high illumination, low illumination. So then finally task is text to speech conversion. That is a different thing. So we need to convert that speech, and that API we utilize and we implement it. So we have implemented YOLO as a quick, accurate object detection algorithm in TensorFlow, and we gain proficiency with the constraint of the system. And the map figured from the pre-trained system constraint as the extension of the transfer learning. So that means we are using that method, and the current usage is restricted for the situation it can effectively identify. So image fidelity, frame rate to be very high, and object cannot be move high speed. That means frame rate also one of the requirements. So if the picture is not clear, it tends move to fast or execution indicates. So for the improvement suggested, we plan to determine the ambiguous over the model loss function by reaching a original touch of a different map value. So these are the some conclusions and the publication on that side. So these are the object detection as I have covered. No, object detection is one of the crucial elements in each and every area in computer vision. So that means object can be anything, like human, like any object, like a ball, like a bat, like anything, like in racket, in the tennis, like that. So the object is the crucial criteria. So object having different category, and it would depend upon the different kind of frame rates. Certain latency is one of the, so real time scenario it would be able to test for us. So for that, that is my next work we are working. That is very challenging area actually. It is not easily done by the people because resources are very tough and training data set is very highly not very highly difficult to collect. So this area, the people are working. It would be very tough, but it's very challenging area. Many industries are working. Many startups are also working. But the main problem is that the data set is not freely easily available. You need to work for that. Even though the ground truths and whatever the annotations data will require, you have to create by yourself only. That's the main issue. But anyway, it's a very challenging in today's trend. From the past 3 4 years, many people have started, but still very many applications can happen in this. So this is the next topic I am going to start. That is computer vision in sports. Even we know for that we must know about what is computer vision, what are the computer vision in sports, what are the examples, and how computer vision used in different sports. And I will talk one of the implementation what we did in our lab. That basically we started last 8 to 9 months, so we have some results. So as we know, computer vision means similarly we have the eye, same time we have the brain. So eye should coordinate with respect to brain. That's it. So similarly, the camera should have calibration. So we are just focusing on the camera on the object. Object will be recognized and it will be stored into the computer, and computer will just process and provide the decision making. So for that, first we should know about the basics of image. So imaging is a basic requirement. So as we are looking, the image is like image only for us. But as a computer and machine is looking, the image would be a pixel. Image would be a data only. In terms of data, it would be a digital data that the computer will understand. So that means some of the information will be extracted, it will be converted as a data in terms of pixel bits like that. So that means representation would be like that. So computer vision is used in sports for several kind of benefits. That means what is the requirement? Why people are worrying about the sports? So it's a entertainment requirement, and not only entertainment, everywhere. This is the requirement. So we can improve the broadcast. That means main aim is to improve the camera. So as we know very well, in today's trend, there are multiple high quality cameras are available for the different kind of telecast or broadcast. So improving broadcast, viewer or audience want to see properly. Even at the time of in the ground, also people are having some audience. They are looking on the scores, everything there. So improving the training process of professional athletes. That means you basically what is exactly happening in the today's era. The many parents are sending their children to go in the sports, but the sports will require proper coaching and perfect coaching. So what exactly coaches are doing nowadays? If you talk 15 years back, like when Sachin was playing, when other players are playing, at that time the coaching was totally different. It was depending on the only the willpower of and that is the condition of the who want to play with them. But today's there are too much technologies arrived. So like you can see the we cannot compare with Virat Kohli to Sachin Tendulkar. That's different. He came in the 90s and at that time the technology was started. Now last 10 year technology has tremendously improved at high level. That means if today someone want to play, someone want to learn, so they are using some gadgets. So they are showing like how to train, how to coach. So they are showing how to just smooth the ball, how to just smooth the bat, which direction they need to apply the bat. So there are different sensor has implanted into a bat. And even not only cricket, there are other applications like soccer. So those are utilizing. There are different activities. They are training the process professionally. They are giving athletics also. There are many athletics people are facing problems, so the training can be improved. Even automated sport analysis, that means automatically decision can happen taken by the umpire, or the free can take that decision by the connection of the just third umpire or any outside of the umpire with respect to interpretation can be taken properly, and helping improving the referee's decision. That means accuracy in the decision will have more advantage. And commercially benefits. That means there are different commercial applications. That means so many industries they are providing different small gadgets. They are providing small bats or they are small balls. Sensor-based systems are coming. So computer vision will be helpful in this kind of benefits. So that means application side we can see because these are the motivational requirements. So first of all, we should know there are some different hockey or different kind of games are happening in overall in the world. So improving the broadcast, your experience, how you are looking. So you have seen Hawkeye. Previously, when we were watching the cricket, Hawkeye was showing like that how the ball will move, where the ball is moving, like that. How the action of the bowler will be there. That is where you will compare two bowlers. So that action also will be there. So today's, as you know, speed of the ball can be easily detected. Or that is stumps are there in the cricket that having the LEDs. So simply there are different and just a small that means motion will be there. LED automatically will bring. So that can be easily detected. So accuracy has arrived into the decision. Previously, there was so many angles. Empire was watching. Third empire was watching for the run out case, or in the no ball also. So that was the tremendous improvement as arrived because of sports in comparison and started involving the sports. So we will also want to see different angles. So what is the position of the so that system will describe, we'll see like that. You can see drawing a virtual marks. That means there are different marks you need to draw on the ground. So improving the broadcast and viewer experience side. That is also that you can see the circle also they have drawn. A particular player also can be should be available on that side. So like that, they are drawing virtual marks. Even estimation of center of mass that is also required for athletics. You can see how the action of this athletics is available by manually fitting off skeleton. That means that skeleton has created. So like in you can see in the LPWDC one, where the ball is going to move after the ball has just stuck on the pad, or it would recognize either it will go in the that is middle stump or which stump it's out of the stump. It can be easily so that can prepare a particular lines and like that. So estimation of center of mass by manually fitting a skeleton model. This is another improving. So that means here we can improve the training. That means how the this athletics can improve his activity so that professional trainers can take this kind of snapshot by the camera or by their own gadget, and they will try to help the player to improve their efficiency. So this is one of the requirement. And tracking of players in sports games. So there are different tracking also will require. So that means we can judge how the player is moving and which player is more. That means it's a one kind of activity player is repeatedly utilizing. That means if you'll see the bowler is always trying to out any one player multiple times. Why? Because he's watching his own video, which shot he's playing like that, which shot he will play like that. So these are the some requirement people are doing with respect to visa. So automatic sports analysis interpretation also. So we can track the player in a sports game. We can see, we can take the referee, we can improve the referee decisions with respect to automatic type. This is one of the helping improving the referee decisions that you can see. This is the ball. So how the ball is moving, where it is moving like that in different games. Hockey in tennis system. So this is the application side. People are working on that and real time billboard. So previously the billboard one need to be applied by the manually, but now it's a real time billboard subscription for the advertisement side in a video system. So this is a commercial benefit. So they want to utilize their own commercially. People want to do some advertisement. That also will be helpful by this simply this way. So there are applications what we discuss. In sports, AI was very virtually unknown. That means today AI have tremendously improved every application of the computer. So it was virtually unknown less than 5 years ago. it was not particularly available. But now today deep learning computers are making their way into number of sports industry applications. So whether it is used by broadcasters to enhance the spectator experience of the sports or by clubs, that means many clubs are there. So there are different clubs nowadays, and different sports agencies are there. So they are providing become more competitive and achieve success. The reality is that industry has the substantially increase its adoption to this modern techniques. So major sports involve fast, accurate motion. That because these kind of sports are having a very fast frame rate. So sometimes becomes very challenging for the coach. That means supposed to be one bowler is doing fast speed. That means you can predict 140 mil per hour or 135. So the speed, if the speed will be there, it is very difficult to predict the ball or track the ball. So that is very challenging for the coach and analyze the track and analyze in great details. So the application side, there are different application as we are working player tracking for our side. So one of the key aims when applying a computer vision sports, player tracking is one of the key elements. This involves the detection of the position of the players at a given moment at a time. And the player tracking is a pivotal element of for coaches. That means already I am telling about that coaches will help to improve the performance of any teams, any players. So they allowing team to instantly analyze the way in which individual player move on the field, how individual player are moving, how individual player are playing, and overall information for their team. So the result obtained from a competent system that can be also augmented by machine learning algorithm, and also we can include there are different data mining techniques for the player tracking data. And one of the key element in the image video frames are detected. Semantic information can be generated. That means first image has taken from the camera, and after information has been generated in order to create a context. What action has done, what is the position of the player, what is the ball, where it is moving, or any kind of action, any kind of decision will be created by the semantic actions. And what pass will be there, what run will be taken, or defending will be there. So there are so many applications people are doing. So in that side, first data collection. That is ultimately we need to provide high sophisticated calibrated cameras. So the use of action and event recognition technique aims to localize the set of actions that player performs in both space and time. So that means the players are doing within a, just like a ball has arrived, that plays the ball bat and just it got the four, maybe out, like that the position will be there. So it will go very fast. This technique can detect the event such as goals, penalties, near misses, shots during the video clips by identifying the visual information on the particular environment, such as code color is there. So there are different colors are also there, and there are different lines on the pitch are also there. So the prediction also very difficult. Sometimes the prediction will be based on the ball, player, and ground. So they use the information to classify each action. What is the sport specific groups? They can avoid. They can provide the labels like shot, like pass, or like different kind of sports. So ultimately, action recognition and classification can be used automatically and generate the performance statistics in a match, in a training session, or any kind of shot or pass position will be there. So what are the main challenges are there? What is the issues are there? So as I told, changing unknown environment. That means sometime player is here, sometime player is here, sometime that is the location is different. And the light also. So we have seen so many times because of the light, the game, because test match, it is very tough. So lightning is a requirement in the every game. Background, because background will have the particular field, will have different colors. So that means that is also very challenging. Clothing also there, different two teams, different clothing and different numbers. Scaling, moving camera. So also multiple camera also will require front camera, side camera, different view also will require. Real-time live performance, provide the innovation and value for money. That means many people are watching with respect to that. They should get output. They should get value for money. Robustness, it will sustain to any environment, any condition. So the accuracy also will be there. So these are the conservative regulators and critics. So different way there a problem will arise. So we need to handle this all kind of challenges. So what are the technologies people are working? So from the training and performance point of view, understanding the sports first. What is the sports is there? What is the performance of the sports? What is the requirement of that sports? And we need to improve the performance. We need to provide different trainings. And also there are so many injuries will happen. So that means the realization after injury. Also the player has to know. And from the spectator or viewer's point of view, telling the story. That means they want some highlights. They want to see some player details. So whatever the player details are there. This is the Cristiano Ronaldo. This is the ballet. So what is their location? What is their performance in the last games? And like that, that people watch the information, but from the user point of view. And camera is the very crucial elements in the sports. So from the training and performance point of view, nowadays people are using small gadgets like mobile phone and different kind of gadgets are given by the industry. They are able to give some technology to the coaches that they can understand the sport performance. They can also improve the performance from the spectator side, telling the story. Spider camera also there, or you can see that there are different cameras are available on the stumps and in the cricket. So that means spider camera, pole camera, stump camera. There are different cameras also will provided into that particular sport. So ultimately these are happening because of computer vision. Computer vision is nothing, the vision will be provided and we can capture multiple frames and we can provide the AI. That means the decision can be changed, decision can be varied. So we can measuring the dimensions. There are different angles of the balls will be there, cameras will be there. So that means camera will have the different dimensions. So origin is defined as the center face of the circle. Ring borders are measured using the laser finders. Camera position calibration also. So both there are different cameras, IR cameras, broadcast cameras. So that means we have to identify some of the pucks we have. Just ball will be there, puck will be there, placed at particular known location. Now we want to detect. So that camera will view any object. So puck is nothing, it's object. Software compute a camera position. What is the location? That angle and distortion also will be there. So we can correct the distortion by using of both camera and compute the maps. So that can be possible with the help of computer. So camera point of view, the footage is usually acquired through one or more cameras installed at the close proximity of the event active. That is ultimately whatever the camera we are using. In terms of that, we acquire one or more camera, install a particular proximity where the events are happening. And sidelines of the training field of in stadium during the match. And the particular angle, particular position, particular hardware, and filming configuration also very crucial. Can vary from the sport to sport. It is not necessary same angle will be there in tennis, lawn tennis, or same angle will be there in case of cricket like that. So event to event, it will vary within the different camera used. So it's same made for training session. Sometimes it will require for training, sometimes for actual. So this can pose a change. That means whatever the pose will require. So there are different pose will be there in the sport. So certain computer application to accurately detect and precisely position of the object also, that means player, where is the player, where is the ball, where is the location of the whatever the static objects are there. So like in cricket there are stumps are there, like the field also there. So that direction of movement that may fail to understand the varying the configuration, so that is used to capture the different footage presented to them. So it is for training the model and classifying new and unseen images. So traditionally, costly camera calibration for multiple camera training system was essential ball and player tracking system. So this was the involved in current kind of camera. That means whatever the camera calibration people are doing for multiple camera training system, and that the essential requirement is we have to provide ball and player tracking system. For the fixed camera, that could done only scene calibration. That means where the ball and were rolled over the ground, that should be taken into account for the known penalty of playing surface. So there are different categories of camera need to be applied. So the broadcast camera present additional challenges in that often change their pan, tilt and zoom. So as we know, the camera will have different parameters. So that parameter need to be varied. So the dynamism needed to, that means whatever the dynamics we need to apply using the sensor of the camera, that where we need to mount, where the lens should be clean, what is the position of the zooming, what is the setting of the camera, it should be able to relate with the raw values, and we should create the particular angles and focal length. So this is the basic requirement. So this is also one of the challenging tasks for the particular vision based system. So gaining process of this advanced filming equipment, that means it is based on the equipment, not often to option for the most profound analysis. That means it is not easy to collect the training data also. For that, camera calibration is a very crucial element. So we can analyze the different departments, the sports clubs, limiting their capacity to apply advanced tracking of techniques. And computer vision has the particularly solved this limitation. That means by the computer vision, by the advanced cameras, now we are not struggling that kind of thing. Within this application, image processing, computer vision systems are not able to distinguish between the ground, player, and foreground objects. It's very easy. So that kind of capability, that is called camera has become the salient camera. So what are the uses we are doing? So augmented reality that aid the stimulative graphics, analyze the scene, that should be extracted data from the statics and graphics, combine with other images, compare with different competitors, and synthesize a new image to get a new viewpoint of view. So augmented reality, that means explanative graphics. You can see that is the red bed media, vision, that they have applications. ORAD wizard. So these are the different scenes. We can add the particular graphics for the explanation purpose. Similarly, that means augmented reality, different spatial camera or image feature tracking. So you can see the different objects have been tracked or identified with respect to particular case. So that is also we can use analyze the scene. That means you can see in the cricket is a very crucial thing. 3D ball tracking using the multiple cameras. So there are multiple cameras or hybrid cameras are also available. So the people can identify what is the position of the LPW, what is the position of the balls. The bowler is where it is pitching on the ball. What is the position of the pitching of the ball? So that can be predicted. What is the location of the ball? Where the position of the players are there? So that can be guided to a coach or trainer to take the action, to give the decision or to train the batsman or to play. These are the some 3D ball tracking is multiple cameras with respect to cricket. The combined with other images for different competitors like input. We have segregated by background subtraction algorithm, foreground and background. This is background separated, so object has predicted only. So what is the position of object? What is the skeleton of the object? What is the position? What is the activity of the object? That can be compared with respect to different. So we can play. We can compare with our competitor. How this player is playing. How I can play. So the coach can guide the player. You have to take that much effort. You need to apply that much. But such kind of information as an input will be given, like synthesis of new images to get a new point of view. You can see what is the position of the object in different frames and can be identified, and we can synthesize the final viewpoint of view. What is the position should be required in a particular image. And thermal images, no privacy issues, so mostly we are using like that. So thermal images will be number of images that can cover the code, and image staging, that means multiple images can be combined to cover full background. That means to cover full image. That means two images can be combined is possible. So foreground extension, background and foreground. So object can be predicted with the help of this method. These are some segmentation problems. So example of occlusion is one of the main problem. Reflection is one of the main problem. There are different fragmentations also will be there. So we have to segment the objects. So segmentation also semantic segmentation. This is a split and short candidates. So split horizontal, split vertical, and short objects. So these are some. So how computer vision used in different sports also. That means not only one sports are happening in different multiple sports. So in racket, bat and ball sports, such as tennis, badminton, cricket, computer has been widely used since mid 2000s. And ball tracking system attempt to look through each camera. That is whatever the ball tracking if you are doing, the system has to take through each camera image available to identify possible object. That means resembling the characteristic of ball. What is the position of the ball? We need to search the ball. So the ball is very small and very fast process. So we have to identify in the particular image. Once the object has been detected, the construct 3D trajectory, playing. So what is the baller? What is the playing of ball and linking with different frames. And the ball was detected with different. We determine the ball has landed in or out bounds. or the system provide the further analysis. So such kind of prediction of the path in the cricket ball would have taken if the batsman had or not hit it. That means that kind of action can be recognized with respect to different games or crickets. So computing system for taking a player, so that is a very crucial requirement. We have indoor sports game, we have outdoor sports game. So player temperature, temporal trajectory also will be very important. So for that case, what is the role of the computer vision? So that means we need to determine the particular players. There are different cameras as placed with respect to different angles. So this is the players. So for that, mathematically, calculation is a very crucial require. That means there are different trackers are available. So like that, Kalman filtering, Kalman trackers are there, article filtering. So based on that, the ball can be tracked, player can be tracked. So for that, we can see the mathematical requirement. So first of all, we need to see the trajectory of the ground. Based on that, we need to identify the angle calculations, how the angle is moving. So you can see this is the one of the calculations. So alpha angle will be there, dr is the this is the and dr is one of the thing. So based on that, we can calculate particular angle, cos r10 r by h something. So these are the position, and we with the help of these positions we can manage the calibration. Whatever the calibration was distorted, we can provide that one. So player taking, mostly we are doing motion detection. So motion detection, mostly previously we were using, there are so many Lucas Canadi methods, or there are different optical flow method. That means we are able to calculate the velocity of the particular pixels. So and one more thing we are doing, mostly first we are doing by background and foreground separation. But then background detection we are doing. An object can be predicted by the removing of the background, and based on that background subtraction method we are doing. It could be a temporal, it could be a spatial. So subtract each frame. That is, C is the reference frame, R is empty count. First frame is your constant frame. We are subtracting second frame, third frame, fourth frame. By that way, object will be predicted. So and also every frame will have some noise. So we need to apply some filtering and threshold. So mostly we are doing binaration. Binaration means we can keep the threshold. Based on the threshold, there will be some pixel will be there. Will contribute to background. Some pixel will be there. Will contribute to the foreground. So based on that, object will be predicted. But the problem is occlusion. There are different false data also to be predicted, because sometimes the maybe leg of the player will distorted, maybe head of the player will be distorted, or maybe ball will be distorted. So there will be many form detection due to the shadows. And also shadow is one of the crucial. So shadow detection also will be required, noise removal also required, human also intervention also required. So for that, first of all we need to apply some template. So template matching, template tracking is one of the tracking algorithm. We have some template. Based on the template, we match on the particular place in the pixel where it is moving. So there are 2D templates, 16 cross 16 we can apply on this frame. So there are different formats are available based on the template. So 14 formats are available. Based on that, we can try the player tracking. And one more template tracking, we can calculate the each pixel, and each pixel will have different channel RGB and compute the correlation. So we can compute, we can coefficient. So whatever the similarity will be there, it would be one. Whatever similarity will be zero. So like that object will be. So we will represent the player in appearance. And like that, some template tracking, there are some calculation will be required. So like different mathematics we are doing, the distance between two points. So like that, there are different distance measures will be required. So Maradona one is distance also there, or different distance. So measure calculated from comparing with respect to one point, another point, and then each pixel. So you can see this. This is the DGCF, distance between two values, and then DFG, and then that we can calculate as. So by that way, we can calculate the particular player. And so there are different tracking we can apply with respect to templates. So first image is real player image, then difference image, that means background, similarity measures have been calculated. So some color tracking, that means by the texture also we can identify with different color. So based on the prior knowledge, player's uniform color. So CRC, CD and C, that is RGB color images. So this algorithm will search each pixel with the most similar color of the players in limited area. So that position we can calculate the similarity measure. So that can be given to the 45 interventions, 80 meters times 0.4. So like that, three methods we have tested: motion A, motion B, motion C, three different. First we applied motion detection, second we applied color tracking, then we club color tracking, color plus template tracking. So we tested 30 seconds for handball match and 50 seconds for so where the player stood still, measure the distance. So these were the calculations summary. So semi-automatic system that output player trajectory. So first of all, there are different mathematically analysis also will be required in terms of sports video because trajectory is a major role in that game. So human interventions are required for error-free performance. And three algorithms approaches we have tested. System can serve as our complete sports analysis system. Semi-real time can be achieved as the best, and resolution was very low, but each player take. So these are some poor results was available. So for that we need to improve. So we are trying different data sets. So despite the great potential that computer vision can bring to world or sports field of the performance analysis, so there are still critical challenges need to be overcome before the potential can be fully exploited. And some of these challenges relate to fact that computer vision cannot be yet fully compete with the human eye. Because we cannot say everything can be done like the human eye. So a system that fully autonomous video analysis of the sports by tracking and labeling of the players remains a challenge for optical tracking system that cannot be cope up with the wearing body posture. That means there are different features are available like body posture of the person during the sport exercise as a well partial or full conclusion of the players by the equipment. So tracking of the sports player also very particularly challenging due to the fast and erratic motions. And similarly, appearance of the player in team sports often close to interaction between players. That means suppose two player will combine. So it will be also hectic case for the sports video. And tracking of the ball further challenging in sports video where the several players can occlude with the ball. That means ball and player will combinedly work. So that means in that situation it is possibly players are in the position of the ball with their hands or between their feet. So these are some issues need to be resolved with us. So finally, in the computer vision, CV used sports for the broadcast purpose, training purpose, automated analysis purpose, decision making and commerce. In broadcast enhancement, auto analysis of detection is often needed. Hockey puck tracking and player tracking systems were discussed. Most of the CV technology in sports is implemented in industrial product and not properly documented beside the patients. Academic work are not easy to come by these tools for the development. And beside the technology challenges, progress depend on the acceptance of change in the conservative environment, strict regulations for the real need for them. So this is the sports and work. One application we implemented in our lab. Just show the results. Only. I will try to show some results. So we can see as we are working on the one more sports video that is called soccer. So people can see that to develop a deep learning CNN based model for ball and player detections. So selection of relevant wide range of frames from the broadcast video and to track the player as well as ball in the video. So we have tried in this kind of soccer video. We have tested this data. We have just taken the permission from the some. See, this is the ball is moving. So with respect to ball, as to predict and player also need to predict. So this is another video. So difficulty in soccer is occlusion, blocking of the ball by players itself, and the detection of similar kind of object as the ball. Shadowing is another problem. Change in the object appearance is another problem. So ball and player detection we tried by this first previous work we have seen they have done by thresholding based background subtraction. Then later they tried by player and reference tracking. So they use half transform for feature based method. Later they tried by some other method like the particle filter and all. So trajectory based also based on that ball detection they did. So that matters. You need to know some kernel and feature map, convolution layer. So convolution network need to be developed for that. So we are utilize far CNN model for the update detection. In that case, go to run model we have created for our update. So that is search algorithm. So in that case, this is the you can see this is the boundary box we created to detect the ball also. So for that we have find out data set from the some Chinese university and they have given permission to download. But the problem was annotation data was not available. Still we are trying to improve this method. So 900 frames were taken from each video. So these are the data set for the different field case. These are the logos in the data set is available. This we have done YOLO 3 first for the ball detection only, and later we have designed this algorithm. It is the probability darkness 53 and same, and still we are confidence threshold is 0.3 for detection, and this for threshold for this thing, and finally this architecture already we implemented for the other work. Here also we tried, and after that we tried for the tracking using short algorithm. So for the short online and real-time tracking algorithm we tried. So in that case, the whatever the model we created, we perform the object detection. That after the bounding was prediction and confidence score has been calculated, then we run the sort algorithm for player tracking and box coordinates each player. So arrange the model in pipeline fashion. So this is the particular results. This is the particular results, and these are the real-time results. You can see that ID has been given. So somewhere it is facing problem because two objects are occluded, and for the all frames we have calculated some positive value, negative value. So for the player detection there are F1 score for ball detection 0.8. Still we are improving for that method. So we propose a deep learning based model for detection of breaking of law in soccer video, and we annotated the ball data set and estimated some unnecessary segments. We evaluated various performance metrics like precision, recall, and other model. We observe how model will perform detection, decision, and occlusion situation. We are still working on that area. So that means it is not completed. So we are trying for improving this method. So we are comparing with this different. We are going to compare successive frames, determine the pass. It may do if it is a successful pass or failed pass. In addition, this heat map also can be used to identify the footprint of the both teams, and finally, path for the goalkeeper can also be drawn. So that we are utilized. So that kind of people work can the work people can do the work in this area. And paper I want to show with you. Just 2 minutes only. The last 2 minutes I'll take. I'll conclude the work. Yes. So this is the people are working on that side also, and we also started to that kind of work. But the problem is that we didn't get a big data set. So the work is related with the in cricket to identify the particular decision. That is a no ball decision, and this is the recent work was submitted, some published by some person in the conference. So we are following that work also. So with the help of some startup companies, we are working in that direction also. But still, we are having some issues. See, this is the problem: detection of the fair ball or no ball. So this and LPW. So these are the work inspection V3 architecture. Some researcher has done. So that means they have created this kind of architecture. FCNN plus ReLU plus pool, and based on that, the decision can be identified. That means ultimately what work people are working for taking the decision or umpire decision in automated scoring system. So this kind of work is very challenging for today's trend, because I already told data set is very crucial problem this side, and also there are so many mathematical analysis need to be added for this. Thank you. Any queries?
So, I want to ask a question. I'm audible. I'm Dr. Radha Jain from Prestige Institute, Indore.
Yes, madam. Yeah, I can hear you. Yeah, you can ask the question. Hello? 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 Mohit sir?
Ma'am,
I'm audible. I'm audible.
Yes, yes.
Then my question is, how many image are needed for good training for each class? Suppose we are having 9 classes of object of 6 to 8 mm. I mean, we are trying to identify seed anomalies in seeds, say gehu. So the object size is very small, 6 to 8 mm, and we need to know that how many images we should take for training purpose.
For what kind of application you are looking for, based on that we need to identify.
Sir, my problem is like we just want to find the anomaly detection in grain seeds. So the seed size is
Yeah,
normally
it's
6
very
to
small.
8 mm. And
Yeah, it's very small image.
yeah. So this is how I want to know how many, we should take the images for training purpose.
So first of all, we need to identify a particular data set, first thing, and how many images are available in data set. So we need to determine. Yesterday I told, first of all we should know about what is the three category we are going to fix. First is
Uh,
training, second is testing
yeah.
and validation. So
Right.
based on that means you can take 40% data to the training purpose.
No.
So
This, sir, my question is for training purpose, just to create the data set for training purpose, how many images we should take? Seeds image, 5,000, 10,000, 15,000, or 60,000, like this, just to train
suppose
our model.
you can do two things, madam. Actually, one thing, you have two data sets supposed to be, as what we are doing actually. So
Right.
one data set we are having 10,000 images,
Okay.
and second data set we are having 20,000 images. So what we are doing, supposed to be, we are having COCO data set. So what we are doing, we have trained on COCO data set, and we have tested on Pascal data set. That is totally different. So both of the data set classes and categories are different, but we must try as much as category as much as classes, so that
Uh,
the accuracy will improve. So you
uh,
should, if you have the one data set only, so you just do one thing, you just do differentiation of three categories. Training, you take 40% data, suppose you have 100 images, you take 40
okay.
images for training, 20 images for validation, and remaining 40 images you can take for testing. And you have to vary what is your accuracy will be there. And
Uh,
also test whatever the classes you have varied, like 3 classes you tested
right.
first. So if you increase number of classes 6, so accuracy will improve. If you increase number of classes 9, it will improve the accuracy. So that is the major requirement. So if you have more data, so that means your accuracy will be more. If you have less data, less classes, accuracy definitely will lag. That
Sir,
means training is the
um,
very crucial requirement for us, but you cannot train by 100%. But you do one thing, if you have the two kind of data set, train by one data set, test by other data set.
right. this is what we are doing. But the problem is that is we are having 9 different objects in our data set. The second question is whether we should take equal image for training of all the classes, or we can a prominent grain is suppose chana, then we can train chana for 40,000 and remaining 20,000 is other anomaly, or we should take equal number of images for training purpose.
You are talking in terms of size of the image, or you are talking about in
Number,
terms of numbers
number,
of the.
number of the image.
Okay, number of the image, you have the number of image, so that you can try whatever the possible images will have multiple classes. Whatever the
Uh,
possible images you will have multiple classes. That means you have the 7 to 8 classes.
right,
So in
right,
different direction, you are talking in different direction. And also one more thing, you should have all kind of ground truth. That means annotation data also mandatory if you want
right,
to
right.
test your accuracy as per the training and testing time.
Okay, okay, sir.
So, well, suppose I told about my sports video, I don't have annotation data actually. And I tried to collect data set from some Chinese university, but they are unable to give because of this pandemic. We are unable to get that data. So, what we are doing, we are creating by our own tools. So, if you are having your own annotation data, ground truth of 100% images, anyway, you can take 40% for training and 20% for validation, or you can do 50% you can do training, 50% you can do testing. Validation, if it's not necessary, you can skip that one. So 50% you can do, or you can do 100% one data set and test by another data set. That also possible. But you want to cover same classes, so you should have same category of the class in both data sets.
Right, sir. Thank you very much, sir.
Okay.
Hello, hello, sir. Am I audible?
Yes.
Sir,
Yes.
good
Yes.
afternoon, sir. My question is: in case of plant and crop, machine learning and deep learning both are available, but which one is the best for disease detection and insect pests identification?
You are talking for medical imaging.
Sir, crop images, plant and crop.
Okay. Actually, one of the application. Yes. So in that case, I have used inspection V3 model. Even I have one book chapter also there. So in that case, if you are having real time pictures of your data set,
Yes,
so
yes.
mostly the problem in the crops. What exactly your question?
Sir, my question is: machine learning and deep learning both are available. Which one is the
Yes.
best for disease detection and insect pest identification? Sir, matlab
See,
which
one
one is
of the
best?
things that machine learning also will be okay if your data set is limited. Okay.
Okay.
But if you have more data set, supposed to be agriculture side, one of the major problem is that data set is easy, readily not available. Okay.
Yes, sir.
So, and even data set is available, but depend upon the application. Like you want to use rice crop, I want to use some other crop, and the country also different country, different data set. So you are working for Indian scenario, the crop will be different. If you are
Yes,
working
sir.
for Europe scenario, crop will be different.
Yes, sir.
So if you are having less features, because crop will have very different, very limited features. We are working here for feature extraction actually. So I told deep learning or whatever AI we are using, it's a big field AI. In that AI, machine learning is one of the area. So
Okay.
previously we were working on the handcrafted feature. That means we are doing feature extraction. We are applying some classifier. So
Okay.
in case of disease detection, we have only two classes. Either disease is there, either disease is not there. Get accuracy somewhere. If you'll apply by deep learning, definitely you will get more improvement. So if you are current trends, people are working for machine learning instead of machine learning, they are applying for deep learning. Or one more thing you can do, you can club machine learning with your deep learning. That means supposed to be classification task, you can add at the end your SVM, and better accuracy will come out. That can be
Okay.
possible. Hybrid kind of thing you can do. So better challenging things. Agriculture is not big challenging. That's the main issue. But if you are working biomedical imaging, I will suggest you are going to do some work in deep learning side,
Okay,
but
sir.
instead of machine learning, because more data, more classes. I think so. You
Okay.
are.
Okay. Thank you, sir. Thank you very much,
Yeah,
sir.
you. Any other question?
Any other query? Okay, sir. I think there is no query.
Okay.
So, good evening to all. I, Rashmi Pant, welcome you all. Now it's time of valedictory session. So, I would like to welcome Shri Aditi Vashish sir, Vice Chairman, MIT Group of Institutes, Ujjain, Dr. K.V. Sharma sir, Professor and Dean Administration, MIT Group of Institutes, Ujjain, Dr. Vivek Bansal sir, Director, Mahakal Institute of Technology, Ujjain, and Advisor, TEQIP RGPV Bhopal from private institutions. Now, I also welcome our galaxy of speakers, Dr. Mohammad Farukh Hashmi from NIT Warangal, Dr. M. Sandhya from NIT Warangal, Dr. Vipin Kamble from IIIT Nagpur. I also welcome to Dean and Head of the Departments of MIT Group of Institutes, Ujjain, and all the participants of FDP. Now, I would like to invite Dr. K.V. Sharma sir, Dean Administration, MIT Group of Institutes, Ujjain, to address us.
Thank you, Rashmi. Good afternoon, all the participants, speakers of today's FDP program on latest trends in computer vision, technology and applications, which is organized by EC Department of Mahakal Institute of Technology. First of all, I want to convey my sincere thanks to Professor S.C. Chobe, TEQIP 3 coordinator of Rajiv Gandhi Pradhyogiki Vishwavidyalaya Bhopal, for given approval for such wonderful and interesting FDP in Mahakal Institute of Technology. In FDP, all sessions are interesting and knowledgeable, and the resource persons, Dr. Mohammad Farukh Hashmi, Dr. M. Sandhya, Madam from National Institute of Technology, Warangal, and Dr. Vipin Kamble from IIIT Nagpur. They shared their research experience and their knowledge with the participants, which is the best part of this FDP, and it will be helpful for all. I also want to congratulations to the FDP convener, Professor Saurabh Ghose, Head of the Department, Electronics and Communication Engineering, Coordinator of FDP, Professor Mohit Pant, and Co-Coordinator, Professor Rashmi Pant, and all members of Organizing Committee, Professor Ashish Verma, Professor Vineet Kare, Professor Prachi Jain, for successful conduction of the event. Thank you very much.
Thank you so much, sir, for your wishes and valuable words. Now, I would like to invite Dr. Vivek Bansal sir, Director MIT Ujjain and Advisor TEQIP RGPV Bhopal. Sir is also currently working on relationship of maths, physics, engineering and music. Sir, we also want to listen brief detail of your work also, sir. Please, sir.
Thank you very much, Rashmi. Now we have reached to the concluding session of the very beautiful FDP, rather I will say, full of applications, experience and new things. That is the latest trends in computer vision technology. 17th and 18th August 2020. I'm thankful to Dr. Hashmi sir for a very, very interesting topic of application of computer vision in sports. We could see the live sports going on and how the decisions are taken, how the things are being done. So I remember when I was in government colleges at that time also, we had a machine vision system and a robo vision system, and for identification, for the image grasping, and according to which we could take the decision for the quality control. That particular robot will pick the defective items from the conveyor, and it will keep the defective items away. And that was done on the basis of the image grasping system. The image of the item was there with computer vision, and he could differentiate. This I could remember regarding this particular work, but it was a very, very important faculty development program and interesting also. I'm thankful to Dr. Vipin Kamble sir from IIIT Nagpur, Dr. M. Sandhya, NIT Warangal, and of course, Mohammad sir has given his presentation on dealing as well as object detection and computer vision application to the sports. So really it was very, very interesting. I'm thankful to our Vice Chairman, Shri Aditya, because due to his enthusiasm only we could arrange these good seminars and FDPs. And I'm also thankful to Dr. Chaube sir. He's in charge of RGPV TEQIP 3. Thankful to Vice Chancellor RGPV Shri Sunil Kumar sir for his initiation for TEQIP 3. And I'm also thankful to the convener Saurabh Gaur sir, Head of the Department Electronics and Communication, the coordinator Professor Mohit Pant sir, Dr. KV Sharma sir, Dean Administration, MIT Group, for their support in conducting this fruitful faculty development program. So I'm thankful to all the speakers again, and Dr. Mohit Farukh Hashmi sir for a very wonderful presentation. Thank you very much. Now it's over to Mohit Pant, Hashmi Pant for further proceedings.
Thank you so much, sir, for your wishes and valuable words. Now, I would like to invite Professor Saurabh Gaur, sir, Head of Department Electronics and Communication Engineering Department, for vote of thanks.
Thank you, madam. अभिवादन शीलस्य नित्यं ज्ञानोपसेविना चत्वारि तस्य वर्धन्ते आयु विद्या यशो बलम. Respected dignitaries, I Saurabh Gaur, on behalf of EC department, extend a very hearty vote of thanks to respected our speakers Dr. Mohammad Hashmi, Dr. M. Sandhya, and Dr. Vipin Kamble, who blessed us with their knowledge and took out valuable time from their busy schedule. I especially liked this session of Dr. Hashmi on object detection, where he explained his research work on application of computer vision in sports. And also I like the Dr. Kamble session on quality assessment in images and videos. Also, I would like to extend a special thanks to Mr. Aditya Vashisht, Vice Chairman, MIT Group, Director Dr. Vivek Bansod sir, Director MIT Ujjain, and Dr. KV Sharma sir, Dean Admin MIT Group, for inspiring us, and Dr. S.C. Chaube sir for giving us an opportunity to organize this. Team members, Professor Vinit Tare, Professor Ashish Verma, Professor Prachi Jain, and all the participants for making the event successful. With the wish of Loka Samasta Sukhino Bhavantu, I express thanks to all. Over to Rashmi madam.
Thank you, sir. Now, feedback link will be shared on the chat box and as well as on WhatsApp group.
Thank you, madam. Thank you, sir.
Thank you, Farukh sir. Thank you.
Thank you, sir.
Thank you, madam. Thank you all.
Thank you, Vipin